Our next story takes us here to Albuquerque, New Mexico, and our nation's premier national security laboratory, where supercomputers, high bandwidth, and certainly energy-saving technology is helping solve some of the most challenging issues and problems when it comes to our national security, as you're about to see. Private enterprises and government agencies alike require huge amounts of bandwidth to meet their communication and security needs. Today, there is a new technology that uses fiber optic cables instead of copper cables to provide phone, data, and video services that saves money, energy, and space.
Every 5 to 10 years with copper-based LANs, you have to pull all those cables out of the wall and replace them with new cables that are rated for higher traffic. With optical LAN, you put the fiber optic in once and it's there forever. You don't have to change it out. The bandwidth on fiber is just enormous. In fact, we don't know of any physicists that have told us the maximum bandwidth of the fiber optic cable.
The need for updating network equipment, containing costs, and saving energy is of prime importance to our Department of Energy and giant labs like the Sandia National Laboratories. As our premier national security laboratory in charge of protecting our nation's nuclear weapons stockpile, Sandia needs high-performance computers that can communicate instantaneously with its vast team of scientists and engineers.
We've always been at the front edge of what was the fastest data rate that was deliverable. We need to get cross-country at high data rates, as well as across this laboratory at high data rates. And so we're always at the very largest speeds.
Sandia found the high bandwidth needed for this speed and communication while saving energy by switching from conventional LAN that uses copper cable to fiber optic LAN.
And that's a big savings in terms of energy. So for Sandia, our particular installation, our particular site, which is very large, we will save about 65% of the energy that we're currently using once the system's fully realized.
Fiber optic means the instantaneous transmission of secure information at gigabyte speeds. High bandwidth technology that is now being deployed to the farthest corners of its Albuquerque campus of 13,000 users in 265 buildings. A transition Sandia estimates will save up to $20 million over 5 years, as well as valuable building space.
We're saving what would have taken us, say, a rack that's a 2-foot square, 7 feet tall, where we might take 3 racks to deliver communications to a set of users in a building. We'll use something the size of a microwave and deliver up to over 8,000 ports. It's a very, very large space savings, and that means cooling savings, real estate savings, just a better leverage all the way around.
What used to be an endless mass of cables and wires of a copper-based Ethernet LAN system is now a single-mode optical fiber cable delivering high-speed information throughout the national laboratories. This optical LAN system, developed by a company called Telabs, can save up to 80% in power use, cost less than half as much as conventional LAN, and provide a 90% reduction in space needed for installation of the network. That amounts to huge savings in IT costs and energy, as well as added security.
Telabs is about advancing networks and changing the way the world communicates, like we're doing here at Sandia National Laboratories. It is showing how to get higher bandwidth, more reliability, better security, all for half the price, 1/5 the energy consumption, and 1/10 the space.
When this is all done, we'll be saving about 1 million kilowatt hours per year. And those are the right kinds of things to do so we can apply ourselves and our resources the most effective way we can.
National security laboratories and enterprises alike are seeking innovative ways to lower their costs. And like Sandia, more and more are choosing passive optical LAN technology like Telabs for a greener, more energy-efficient way to deliver information in the workplace.